To begin, we are given the following equation. We can now evaluate both sides of this equation by plugging 3k and k plus 1 into our function. From here, we can expand both sides, and now we can simplify the right-hand side. From here, we want to get all of our k's on one side of our equation, so let's add 6k to both sides. From here, we can subtract 3 from both sides, and finally, we'll divide both sides of our equation by 4 to get k equals 1/2. Now keep in mind that our goal here is not to find the value of k, our goal is to find the value of f of k. So we'll now plug 1/2 into our function. When we do, we get the following, which we can now simplify to be 4. So our answer is D.
This is an interesting problem. So, first of all, y could be positive or negative. It could be, for example, positive 5 or negative 5, but since we're going to square them, it doesn't really matter, so we might as well just consider the positives. More importantly, what is the highest value that y could have? What is the highest positive value that y could have here? And this is where there's a mathematical trap. If people are just thinking in terms of numbers as positive integers, as if the only possibilities for y would be 4, 5, and 6, well then the highest value would be 6, and of course 6 squared plus 5 is less than 50. But here's the thing, y could be any decimal. It could be 6, it could be 6.5, it could be 6.9, y could be 6.9999999 with 9s going all the way around the block. Okay, let's say 1,000 or 2,000 9s after the 6.9. And so that would be a number astonishingly close to 7. In fact, when we squared it, of course it wouldn't be exactly 49, but it probably would be something very much like 48.999 and then 9's halfway around the block and then maybe a few other digits. But the point is, we could get something very, very close to 49. We certainly could get the square root of 48. Y could be the square root of 48 because that is a number between 6 and 7. It is certainly less than 7. And then y squared would equal 48. And then y squared plus 5 would be 53. So it is certainly possible, for example, if y is 6, column A is smaller, column B is bigger. But if y is the square root of 48, that makes column A bigger. So we can make some choices that make column A bigger and some choices that make column B bigger. And because the relationship changes for different choices, the answer has to be D.
In this problem, A is the initial amount put into the bank, and R is the annual percentage of interest written as a decimal. Now that's very important because what that means is we can form a multiplier simply by adding 1. 1 plus R is the multiplier for the percent increase, 1 plus the percent written as a decimal. That's very important. That means that every time we have a percent increase, we're going to multiply that. And since it's compounding annually for 3 years, we're going to multiply by this factor 3 times. So we start out with A. That's the initial amount. At the end of 1 year, we multiply by the multiplier. Distributing, we get A plus AR. So at the end of 1 year, that's the principal, that's the interest. Then we take that entire amount, A plus AR, this is compounding, so it means that entire amount is hit by the multiplier again. Now we distribute, first multiply by 1, we just get A plus AR. Now multiply everything in the parentheses by R, we get AR plus AR squared. Simplifying, we get A plus 2AR plus AR squared. Again, this is the principal, this is the interest after 2 years. Now this whole expression, A plus 2AR plus AR squared, which is the total amount at the end of 2 years, this all gets hit by the multiplier a third time. So first of all, what we get is multiply by 1, we get that entire expression as is, multiply by 1, And then we get the entire expression multiplied by r. So I'm just going to offset it, writing it below here. We get ar plus 2ar squared plus ar cubed. And then adding, we get 3ar plus 3ar squared plus ar cubed. And again, this is the principal, and all this here is the interest after 3 years. And notice, if we factor out an a, what we get is answer choice C. And answer choice C is the correct answer.
Alright, so we have a quantitative comparison question on our hand. The given expression is in factored form, whereas the expression in column A is not factored. So let's do something. Let's FOIL this out. X times 4y is 4xy. X times negative 2x is minus 2x squared. Negative 2y times 4y is minus 8y squared. And negative 2y times negative 2x is plus 4xy. We have this equal to negative 12. Let's combine the like terms. We have negative 2x squared. 4xy plus 4xy is 8xy. So plus 8xy minus 8y squared is equal to negative 12. Now we see that we have a x squared over here and we have a negative 2x squared over here. And we can also see that all these terms have 2 or negative 2 as a common factor. So we can take out a negative 2 as a common factor. Let's go ahead and do that. Negative 2 times x squared, positive 8 divided by negative 2 is negative 4. So minus 4xy. And negative 8 divided by negative 2 is positive 4 plus 4y squared is equal to negative 2 times 6. That's negative 12. And then we can divide both sides with negative 2, meaning this is gone, this is gone. And we have x squared minus 4xy plus 4y squared is equal to 6. Now if you look at this one, x squared minus 4xy plus 4y squared is exactly what we have in column A, and that's actually equal to 6. So we have 6 in column A, square root of 6 in column B, and therefore the quantity in column A is greater.
To begin, we are told that the average of y numbers is x. So using the following rule, we know that the sum of those y numbers must equal x times y. Now if we add 30 to the existing sum, then our new sum becomes xy plus 30. To find the mean of these numbers, we're going to divide by y plus 1, since we have added one number to our set. And we're told that the mean now is equal to x minus 5. We can now solve this equation for y. First, we'll multiply both sides by y plus 1. And now we can expand the right-hand side. And now let's add 5 to both sides of our equation. And now we can subtract xy from both sides of our equation. And now we can rearrange our equation to get the following. From here, we'll divide both sides by 5. And finally, we can simplify this to equal x over 5 minus 7. So our answer here is D. To begin, we are told that the average of y numbers is x. So using the following rule, we know that the sum of those y numbers must equal x times y. Now if we add 30 to the existing sum, then our new sum becomes xy plus 30. To find the mean of these numbers, we're going to divide by y plus 1, since we have added one number to our set. And we're told that the mean now is equal to x minus 5. We can now solve this equation for y. First, we'll multiply both sides by y plus 1. And now we can expand the right-hand side. And now let's add 5 to both sides of our equation. And now we can subtract xy from both sides of our equation. And now we can rearrange our equation to get the following. From here, we'll divide both sides by 5. And finally, we can simplify this to equal x over 5 minus 7. So our answer here is D.